Don't bother with recording videos anymore. We cannot upload it on YouTube. How come? I just asked your AI agent that how can I be more productive, and it went ahead and deleted all our social media apps, including YouTube. Are you serious? Yeah. Now listen, I also prompted to turn on this robotic vacuum and finish the work until cleaning is done. And I found it stuck in 6 hours in shower trying to clean even the walls, like auditioning a commercial video for cleaning. Stupid. It's not a stupidity. It's about prompt optimization. Sometimes you feel like you have the best prompt and it is working properly, but there are lots of different automated ways to optimize your prompt and give you a much better version of your prompt through even automated testing, which I'm going to show you how you can do that through some open source solutions, so you don't need to code at all. Very cool. Then, let's go.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Into prompt optimization, and before we talk about different approaches, let's again dig in on what is prompt optimization. The goal here is what we can do to do our best actually to make our prompts much better. That means in a shorter amount of potentially length of prompts, we can be up to the point and get the most outcome from the task of our agent, or any type of outcome that we have from the prompts, which is doing something, calling something, or doing text summarization, or generating any sort of text out of it, to make sure that we have the best prompt in place. But we are not going to do a trial and test here. And you might have a prompt that is working properly for majority of the cases, but you see sometimes the same prompt doesn't work properly for other cases. So we're gonna see how we can optimize the prompts in an automated manner through some open source libraries, and how we can make sure we come up with the best prompt for different use cases we have in place. To the time that I'm recording this video, I'm gonna walk through some of well-known approaches, but it's a very evolving domain, so you never know. After, when you're watching this video again, there might be some better approaches coming in, or even now there might be even more than what I just shared here. But I just want to make sure I quickly wrap up on main approaches that has been proven to be working in the community, and they should be enough for majority of the use cases. So the first one, the simplest one that potentially you're already familiar with, is few shot prompting process. So as you know, in this sort of example, let's say we have some specific data set. We call it here training. We're not going to fine tune a model here. We call it training because we want to use this example data set to optimize the prompts. So what we will do, we usually have some examples giving in to the model in the prompt. It says usually up to 50 examples, but that 50 is not a rule of thumb. It depends on your specific use case, how large is the context of each example. So within your prompt, when you're asking something, you also mention some examples inside the prompt. Hey, I'm asking you to generate a text for doing this and that, and by the way, here are some examples. And then you add those examples to the prompt, and then you have an enhanced prompt right now for inferencing. This is fairly easy, right? So this is best used when your task is well within model's existing knowledge. That means you're asking something from your language model that is not so far beyond internet data, something that these language models has been trained on it. Also, when you have no concern about the length of the token, for example, if you add more examples each time to the prompt, of course you're having longer prompt, and the token cost at the inferencing time gonna be more. But in case if it's not a major concern for you, then it's a good approach to take in. But this is the naive example to start with. What is next? What are different approaches we can start besides just few shot approach? The next one is meta prompting process. This is the one actually we're going to run a code example out of it through an open source package. But what is meta prompting? What we will do here, we have an initial prompt. We don't know if this is the best prompt or not. You come up with a prompt, you want to optimize this. So what you will do, you will take this prompt, run it through some samples data set that you have. For example, you're asking for generating a tweet based on the given topic. So you use that prompt that asks LLM to generate a tweet, and then you will call it again and again, and then you calculate in a score. So you need an evaluator. Here that can be LLM as a judge evaluator, or it can be a metric you hardcode as a function to evaluate how good is your tweet is. For this example that I'm gonna run the code, we're gonna check if the generated tweeter has a hashtag or not. If yes, we're gonna penalize that because I don't want hashtags in my tweets. Like, it's a simple function Python code that I can evaluate. Then I will have another prompt, we call it meta prompt or meta LLM, that I will add my example that I asked to tweet, then the output that what model generated as a tweet, and then the score of that using this evaluator function. Then I will give it to the meta LLM to say that, hey, here's the example, here's the output, and here's how good or bad the example is. Give me a better prompt based on the output that I got. Now you have an updated prompt. You do this again and again until you see an improvement and your scores are getting better and better. When it's improved, then it's my best prompt. You will save it. So when we're going to use this approach, this is when you want to have a specific rules and preferences in your prompt that is not being listened properly. You want to improve it, so that's a good way. And the pattern is not complex, it's clear. So with multiple iterations of meta prompting, you will have the prompt potentially updated, which is better. And you want to have a token efficient solution rather than few shot, which gonna take a lot of token. And again, the task is clear. Your prompt is not complex. That's a good approach, and I found that actually it's pretty useful for majority of the use cases. The next approach is meta prompting with reflection process. So what's the difference of reflection and without reflection, which is the previous one that I told you? It is similar to meta prompting. That means you have an scorer function, you show that example to a meta LLM or meta prompt, but here we will have a tool set to analyze the pattern of when we are failing or when we are improving with the scorer. That can be chain of thought process, that can be the new reasoning models that we see they're getting released, or that can be a human in the loop section, like a human will come in and add something from human perspective to this evaluator and the meta LLM example you're providing, right? So now we are giving sort of a reflection at the middle through some tools or human to this evaluation process. Now we have an updated prompt. Now we're gonna check if there's improvement or not, so we will repeat the process. Now this is good, this approach is good when you want to discover a little bit more complex or hidden patterns that one prompt doesn't necessarily capture that. So for more complex scenarios, this is better compared to just meta prompting. So I would recommend meta prompting with reflection. And you want to make sure you have a computation budget for deeper thinking. That's why you don't want to keep LLM to figure out by itself. You want to add this think tool or critique tool in place to come to the best prompt faster. And you see that simple meta prompting wasn't finding the optimal solution for you, so you will try this approach. Okay, what is next? The next approach is prompt gradients process. So what is this? What we're going to do here, you start again with your initial prompt. Then using the same scorer, you will have an evaluator that gives you a score how good the prompt is, and we're going to talk about that, how we define this evaluator. And then you will have another prompt that generates feedback based on the examples that you failed based on this evaluator. And we start to collect these feedbacks, which we call it here gradients. Then based on the feedbacks of the failed examples that you have, we propose a new update on the prompt. And then we'll do this again and again until we go through all the examples we provide to come up with the best prompt. So when you're going to use that, use this approach when you have a specific failed examples that you don't know why. Whenever you change the prompt, you make it better, it works, but some examples it fails. Try this because it's going to do a targeted improvement for failure examples. And when you want to have a more controlled incremental solution, that's a good one because you go for a targeted examples and make sure you have clear evaluator function or solution like LLM as a judge. And you feel like for scenarios that you require fine-tuning on a specific edge cases. Fine-tuning here doesn't necessarily mean fine-tuning a model. It can be a tuning of your prompt. You feel like for a specific edge means the cases that it's really hard to go them successfully. You need some better instructions, and this is the approach. And lastly, the last approach I'm going to mention here is evolutionary optimization process. So what it does, for start, let's go step by step. Instead of having one initial prompt to start, you will have a diverse of different prompts. They all gonna do the same task, but they're different. They're written separately. Usually, you start with, let's say, 5 different prompts, but they all gonna do the same thing, same task for you. Now we're gonna go and evaluate all these prompts separately by applying that evaluation score or what we discussed, and we see based on the feedback when these prompts are failing or when they're doing good or bad. We do this for all those initial prompts and we update them separately to make sure that they are getting better and better. Now, with all these prompts that they're getting better and better, we select the candidates that they got the most performance after we updated them. Then we combine all these successful prompts from the one that we rephrased and they were successful to find the final optimized prompt. You might say that, MG, this is too much complicated. Why are you gonna do that? So what's the goal here? If you know machine learning, we have divergence issue that we're gonna stuck in local optima spot rather than having a global optimization. Or let me make it a bit simple. Sometimes you fix the prompt for a specific samples and data set, but that doesn't necessarily mean that prompt gonna work with your other examples. Some examples they have different patterns, some other examples they have different pattern. What we're doing here with having multiple diverse initial prompts, we're gonna make sure that we see different batches of data separately and we get the patterns separately and we update the prompts separately and then we combine the successful prompts. So this will let us to have a holistic view of all the patterns in my examples to come up with a prompt that is combination of other prompts that they have seen other sections and complex patterns of my data. So we don't want to stuck in local optimization, we're gonna have a global optimization for the prompt. That's really the whole goal. So this is very good when you need discover a non-obvious solution. This is really for the time that you have much more complex solutions and you realize that it's no way that with optimizing just one prompt over all the examples even it doesn't necessarily work properly. And also it is good when you got stuck in local optima with other approaches that you have tried, and it is also good when you have computation budget like others. And this is good for the tasks that require combining different prompting strategies. This is also really good. Alright, enough talking. We went through a couple of examples, and again there might be even more right now, and it's gonna be even more in future through as I heavily see this is pretty evolving. But let me go through an example that I ran actually, and I want to actually run the rest of the code with you. So the package that I use is PromptTemp. This is an open source package that let you run prompt optimization on your given initial prompt. So I already installed that in my Google Colab. You can run it in any Pythonic environment. You also need to make sure you provide your choice of language model. Definitely you can use any one that you want. And Blacksmith here is just for having traceability added here. I actually got it from the reference code, which I'm gonna add it to the Discord channel, and the Discord channel link on the video description. You click on it, there's a reference section, you will get access to the all code and the open source package I'm using. Alright, here I just needed to actually mount my Google Drive to the Google Colab to the drive. If you run it out of Google Colab, you don't need to do it. And here how we can call this open source package. We say create a task and you specify a directory, and for your task you want to give it a name. So what we're doing here is that we have a prompt that we are asking for, hey LLM, create a tweet based on the given subject. Okay, but we don't know what is the best prompt to do it. We don't want to, let's say, have hashtags, we don't want to have emojis or whatever in the tweet. These are some instructions, but sometimes the model get confused, so we're going to optimize the prompt. Now the initial prompt that we have, it's actually coming from the public LangChain that they have actually stored in Langsmith. So it can be also a string here, it's going to be your initial prompt, so it doesn't matter here really. And the dataset also can be a name or a URL here. Here is again coming from the public dataset that LangChain released about a list of tweets examples, sorry, the topic of tweets that we need to give it to the prompt to generate a tweet. For example, in the dataset example, they have a topic called financial statement of 2024 or 2025, or what's the market right now on AI, any given topic. And then with specifying this task, actually let's run it. We are ready to start by train here. That means optimizing our initial prompt. And of course, make sure you also provide some description on what you're planning to achieve here. So let me click on, actually before I click on train, there is actually a bunch of files created for you after running this create task, which we need to specify the configurations that we need to run this prompt optimization approach. So let me get into the files that has been created. Alright, so we have this my tweet task because we specified this here, and you will see we have config.json and task.py. So if I open config.json, you will see that it has some information about, again, the name of the task, the dataset we're using here, and where is our evaluator. Remember I told you in our prompt optimization you need to have an evaluation, which is a LLM as a judge or a function. This is actually inside my task.py. There's a function called evaluator. I'll open it because we need to change it. And then we have some descriptions added here. Now my optimizer, you can select which model you're going to use for optimizer. You can change it as is. And here's my initial prompt, and the identifier is tweet generator example with nothing. This is technically again generating a tweet based on the given topic. Alright, so let me open task.py. This is actually the main part that we need to modify. As you can see here, we have a function that tell us how we need to evaluate the given prompt results when we run that. So for this example of tweets, we need to change it with what I actually gonna copy and paste here, and again I will add the reference code as well for you, so don't worry about it. Alright, so okay, let me fix the typo. So clearly what we need to do here, we have the output of the prompt that we're evaluating, right? And after having that output, we're gonna check how good or bad is through our scorer function. So here our scorer function is pretty simple. If there is a hashtag generated in the result, which is a tweet, I'm gonna have it as a penalty because I don't want that to happen. So what we're gonna do, we're gonna make sure that we have tweet that omits hashtags, and how we score it through this. And of course a comment here would be for this evaluator to know that what we care about when we evaluate it. So if we are telling that we're gonna tweet, if tweet omits hashtags, so that means if its score is 100% perfect, otherwise it fails, and then we run evaluator. So that's it. So let me actually save this, and of course you can modify that with any different evaluation based on your use case. And I run it. So let's see what happens. So it is actually right now starting optimizing my initial prompt, and here's my initial prompt. Generate an engaging tweet about given topic that connects with your audience. Focus on crafting compelling content, blah blah blah. And okay, I'll let you read the rest. So what's happening here actually, whenever we run this prompt team train, it first load the prompt and data set that we specified in configuration on the top. Then it will evaluate our prompt on a dev split. So dev dataset, training dataset. If we don't do that, it will use the full dataset that we have the examples. And it used the evaluator configured above to give us a baseline metric to compare against all this optimization process. Then it start actually optimizing the prompt, but looping over mini batches of training examples. And for each mini batch, it computes the metric using that evaluator, and then it applies the meta prompt to suggest the changes to the current prompt, that hey, here's the evaluator results and here's the example input and output, give me a better prompt. Then it applies the updated prompt to the next mini batch of the training examples and repeat it again and again. And all this process that I explained you can be repeated in number of epochs. That's why you see this just one epoch being created. Okay, let me go all the way down. I think it should be done right now, hopefully. Let me go all the way. So using our evaluator that we specify, which is a function here, our initial prompt was 94% good. We can call it accuracy or whatever. It's a metric that we specified. But now with these updates, we have a prompt that worked perfectly for all the examples. Now we have tweets generated with no hashtags and stuff with this new prompt with 100% score. Now what is the new prompt? Here's a new prompt. You will see it start with important. Do not use any hashtags. That makes sense, because usually a good practice here is when you have some important notes to mention in your prompts, a best practice here is start it at the beginning of the prompt or at the end of the prompt. It has been proven that LLM remember the better instead of having them at the middle. And because our evaluator was focusing on this, so this optimizer understood that, okay, for making sure there are no hashtags and get 100% accuracy, I need to add it at the beginning or end, and it added at the beginning. And then it will start some good practices. And lastly, remember, craft your message, blah, 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 and no hashtags. Interesting. So it realized that even at the end, as I just told you, it is a good practice to add it here. That's why we got a 100% scored prompt. All right, so here's the prompt optimizer or prompting package that I use. Again, I will add the link to the video description below. There are more inputs you can specify. For example, if you want to have human in the loop, if you want to split your data set to test the prompt on a specific batch of your data and then test the new updated prompt to a specific batch of data, you can do that. So I'll let you read through all to see what is going on. But technically what we ran was the main example on this tweet generator score. Alright, I hope you found this video helpful. At least you have an idea of what is prompt optimization, what are different approaches, and what is a good use case example using open source that I can leverage instead of me coding to come up with a better prompt. But you're certainly welcome to try your own approaches, code from scratch if you want to, if you see your use case is specific, or with your own choice of LLM and the data set, of course, that you have. As long as you know the idea, it's not really complicated to develop and run it properly. Alright, if you like the video, I'll be very thankful. Click on like icon and make sure you write down your comments, your thoughts, or questions in the comment section below. Thank you so much.
The worst downfall is when you betray yourself to take it easy and convenient. Dream big, my friends, believe in yourself and take action. Till next video, see you soon.